This is a video on the area of a parallelogram. The question states, find the area of the parallelogram that has vertices 0, -2, -1, 2, 2, 0, 1, 1, 1, and 3, 5, 2. So our strategy will be to use the formula that says that the area of a parallelogram is equal to the magnitude of the cross product of two adjacent sides made as vectors of the parallelogram. So I'm going to find the two adjacent sides. So I'm going to go from 0, -2, -1 to 2, 2, 0 and find that displacement vector. 2 minus 0 is 2. 2 minus -2 is 4. And 0 minus -1 is 1. I'll call that vector u. Now let's find the vector that goes from the first point to the third point. 1 minus 0 is 1. 1 minus -2 is 3. 1 minus -1 is 2. And I'll call that vector v. Now, just to make sure that these are truly the adjacent vectors, let's go from this initial point to the fourth point and see what we get. 3 minus 0 is 3. 5 minus -2 is 7. And 2 minus -1 is 3. So we can check that if we add u and v, we get w. 2 plus 1 is 3. 4 plus 3 is 7. And 1 plus 2 is 3. So that means that w, the vector from the first point to the fourth point, is a diagonal vector for the parallelogram, and u and v are adjacent sides. So now let us recall that the area, again, of a parallelogram is equal to the magnitude of the cross product of the adjacent vectors. So I find the cross product by setting up the matrix, where the first row is ijk, the second row is the vector u, or its components, 2, 4, 1, and the third row consists of the components of the vector v, 1, 3, 2. To find the determinant of this matrix, I take the first row and the first column, black it out, and I'm left with 4, 1, 3, 2. I multiply that determinant by I. Then I take the first row and the second column, black that out, and I'm left with 2, 1, 1, 2. These are called the minors for the matrix. And then I take the first row and third column, black it out, and I'm left with 2, 4, 1, 3. So remember that we subtract the j component instead of add it. That's part of the formula. So now I find the determinant of each of these minors. 4 times 2 is 8, minus 1 times 3 gives us 5, and I get 5i. 2 times 2 is 4, minus 1 times 1 is 3, so I get minus 3j. 2 times 3 is 6, minus 4 times 1 is 2, and I get 2k. So I take the magnitude of 5i minus 3j plus 2k by looking at the square root of the sum of the squares. So I have the square root of 5 squared is 25, plus 3 squared is 9, plus 2 squared is 4. 25 plus 9 is 34, plus 4 is 38. So my final answer is that the area of the parallelogram with these vertices is equal to the square root of 38. And I'm done with the problem.